All right, hi geometry students. Yesterday we talked about Outbreak, and this is going to be, I kind of read this to you in Module 2. You remember Detroit. This is the city of Detroit, and these circles represented, like let's say this was the first case of a disease or something. After day 0, this would be the area that it would take up. And then after day 1, it would grow, and day 2 and day 3. And so what we're trying to do here is contain the spread of the disease. And so we are going to try to construct a fence around day 3, really. Because we think that it's really at day 2, we think it's spread there, but just to be safe, we're going to go around to day 3. And so we talked about that. And you also will have to not only quarantine the people, but place security cameras around, not too many, but just a few, so that you can contain the people as well. So it says here, you think the easiest fence to build is going to be a rectangular fence that includes the circle, but you want it to be the smallest rectangle possible. So therefore your fence must just touch the very outside edges of the circle. And we talked about that. Tangent line is actually what we're going to be using. So we looked at these examples. Tangents are lines that just touch the edge of the circle. They don't go through the circle, okay, in any way. They're not outside the circle. They just touch the edge of the circle. Okay, so notice all these points, or all these lines or segments touch the edge of the circle, but they don't go through it. So that's what you'll want to write. Yesterday we already wrote this definition, but you'll want to write that a line that touches the edge of the circle just once is what a tangent is. And a tangent, we also learned, was perpendicular to the radius of the circle as well, that it connects to. So on here, number 2, it says construct 4 tangent lines to the day 3 circle, creating a box, and use a protractor. This will be your fence. Okay, so if I look at this, what I did is I already labeled north, east, south, and west looking on this map. And so what I want to do is, again, this is 90 degrees right here. If I look at the center of the circle, this is 90 degrees. That's actually backwards. 90 degrees right there. Okay. And so up here, I'm going to have a point of tangency right here, point right here, a point right here, and a point right here. Okay. Those are all points of tangency, and I just need to make sure that when I draw my line, and I'll turn it around maybe this way. When I draw my line, I want to make sure that it's going to be at 90 degrees. So if I look at this point of tangency right here, it needs to be 90 degrees from this line right here. So 90 degrees, if you look over here, this is 90. Here's 0. So I'm just going to mark here and mark over here. That would be 90 degrees in the other direction. And then I'm going to use those 2 points to draw my line, my tangent line. So now I'm going to connect those 2 points that I just found. Okay. So that is a tangent line right there. Okay. Now I got to do it for all 3 of the rest of these points. So I'm going to turn the page this way maybe. Okay. And what I might do is I'm going to put my protractor on this west point of tangency. And again, I'll find this would be 90 degrees in this direction from this line right here. This would be 90 degrees in this direction from this line. Okay. And then again, I just want to connect these points and make it go through that point of tangency. So again, it looks like that. So you can see we're creating like a box. All right, and then again, let's do this one. Yeah, I'm gonna go this way. No. So I'm lining it up so that it's 90 degrees. This line will be 90 degrees to this line. So I'm gonna mark here at the 0 and at the 180. And try to draw my line as accurately as possible. There's that. And then last one is this one. So, and again, we're creating a fence here to contain the disease. We don't want to go too far out. We want to have this fence around to make sure that no one gets in or out. Okay, so they're quarantined in here. So here's our fence right here. Okay, and then we were asking, what's the perimeter of that fence? Okay, so I think not only did you create the fence, so on here it says, use the protractor, that's your fence, and you've just created 4 circumscribed angles. What are the measures of the angles formed? And then what's the perimeter of the box you made? So this angle from here, like here, right there, that's called a circumscribed angle. Same thing over here. That angle right out here is called a circumscribed angle. Okay, and then same thing here and same thing here. So notice it's outside of the circle, but it actually corresponds with your tangent lines. Okay, so those are circumscribed angles. So I want you to also look that definition up. And then what are those angles? Well, if it's a box, if these are all at 90 degrees, then these should all be 90 degrees. Okay? So that would be our answer to that. What are the measures of the angles formed? They should be 90 degrees. And then what's the perimeter of the box you made? Well, you got to look at how far out. This is where you're going to have to, remember like how far out in miles, let's say, was was this purple line. So it kind of looks like. I think when you guys were measuring this, I thought you guys said that it looked like 1 1/4. So 1 1/4 miles is out in this direction. So if that's the case, if this is 1 1/4, okay, that means each one of these represents 1 1/4. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 1 1/4 is what you're going to have. 1 1/4. So 8 times 1 is 8, and then 1/4 of 8 is 2. So that's 10 altogether. So that's the perimeter, 10 miles around. And then what's the relationship between the radius and the tangent? We answered that. So we answered this yesterday. What's the radius, or what's the relationship? The radius and the tangent line, they are at 90 degrees to each other. Okay? And you drew a picture of that yesterday. Okay. So now that you've got a good start to the fence, we know our fence is 10 miles all the way around. Now we got to think about security cameras. And it says we'll need to find a security camera that has the right viewing angle. So we'll need to investigate where we want it placed. And you only want to purchase a few since they're expensive. So we're going to investigate a viewing angle or a camera basically that would be able to view the east and the west entrances from another point on the circle. So we start by drawing some chords on a circle, it says. So chords. Remember, what is the definition of the chord? You guys described it as a line segment that touches 2 sides of the circle. It goes through the circle and it touches 2 sides. Examples are right here. So like this is a chord. It touches 2 sides and it goes through. This is also a chord. And if it goes through the center, that's called the diameter as well. And then this little thing right here, that's also a chord. It's a little short one. But these right here are not chords. They don't, they're not segments that go through the circle and stop on the edges. This is a line that goes through. That's actually called a secant. And again, this isn't even touching. And then that looks like a tangent line because it looks like it just touches it once. Okay. So then it says here, make a point anywhere on the north half of the circle, not directly on the north point, and label this camera. So I'm going to make mine like right here. And we're going to label it camera. And they also said the X was also another thing they could name it. And I'm just labeling it somewhere in here. You're going to have to kind of label it wherever you would like to, but make sure it's on the north half of the circle. All right, and then it says, make a line segment from the west entrance point to that camera. So if I draw a line, here's the west entrance. If I draw a line from the west entrance to the camera, there's a chord right there. So that right there is a chord. And then it says, make a line segment from the camera to the east point. So now I need to make a line from the camera to this point over here. This is the east point. Now this right here, this angle that you've just created right here, that is called an inscribed angle because it's inside the circle. The other one was circumscribed angle because it was outside of the circle. This one is inscribed. Okay. Now notice this forms a triangle. And notice if you look on here, this line that's going through this hypotenuse right here, that's the diameter. Okay. So when you answer this question, there's a question later on. It asks you from the west to the east, what chord is that? That's the diameter. Okay. So what kind of angle, if you have a triangle that's formed on a top, let's say the top half of this circle, where the on the triangle your hypotenuse is the diameter, what kind of triangle did you form? So let's look. So what angle then is another way of saying it. If you place your camera at that point, X, what viewing angle would your camera need to view the west and east entrances? And it says use your protractor. So we're going to do that real quick, and that'll be the end of this video. So if we look on here, we can see, look at that. If you look here, your angle, here's 0, okay? And then you can see 90 degrees is actually what this angle is. This is 90 degrees. Okay, so your viewing angle should be 90. And you'll find that no matter where you put your point on the circle, no matter where you put it, like if I put it here and I drew my two chords here and here, it's still going to be 90 degrees no matter where I put this camera, okay, along there. So 90 degrees is the answer to no matter where you put yours. And also, you just have to know that if you have a triangle that's formed inside of, like I said, the top or bottom half of a circle, then that triangle will always be a 90-degree triangle, okay?